All right, welcome back. So during the regular semester, normally 6.2, I like to split it up into 2 days. And what we just did was trigonometric integrals. And then the second part would be the trigonometric substitution. So let's talk about a very simple one. Or let's just get right into it. Okay, trigonometric substitution. So all this was trigonometric integrals. And now we're going to do trigonometric substitutions. Okay, so now our trigonometric substitution, let's do a very sort of the simplest one I can think of, or it's the simplest one I can think of. So let's say we have a portion of a circle, radius r. If we're doing this, this is the integral from 0 to r, okay, square root of r squared minus x squared dx. Now, we should all know the answer to this without doing the integral. Is 1/4 pi r squared, right? Because it's a quarter of a circle. Let's do the substitution. Okay, so what we're going to do is a little bit different than the substitutions we've done up to now. Before, we were looking for like the d theta or the du in our integral. Now what we're going to do is we're actually going to put it in. Okay, so we're going to look for the proper proper trigonometric substitution. Okay, I'll give you all. So let's start by noting that, you know what, r squared minus x squared kind of looks like if I do r squared times, well, it's not just looks like, it is equal to r squared minus 1 minus sum 1 over r squared x squared. I don't like that. Let's instead, we're just going to go ahead. It looks like 1 minus sine squared of theta. Okay. What we're going to do is we're going to say, okay, let's let x equal r sine of theta. That's going to be our substitution. Dx is then going to be r cosine theta d theta. Okay, now let's put our integral through this machine. Okay. Okay, so if x equals 0, when does r sine theta equal 0? Well, that's going to be at theta equals 0. Okay. We also want to get theta equal, we want to get sine of theta equaling 1, right? So that we get r here. When's that going to happen? At pi over 2. Spoiler alert, I want you to notice, hey, you know what? That angle's pi over 2. There is a connection there, but let's not think about that too much yet. Now, what are we going to get under the square root? R squared minus, now x is going to be r squared sine squared of theta. Dx is going to be r cosine theta d theta. So far, okay? Awesome. Okay, now let's factor out this r. So when we factor this out of the square root, it becomes r. And then we have this r. So we're going to get r squared out front. R squared. 0 to pi over 2, let's write this as, well, a couple of things. Notice we have the square root 1 minus sine squared of theta cosine theta d theta. Now, since theta is from 0 to pi over 2, this thing's actually always positive. Okay, sine of theta is between 0 and 1. So that means I can replace this and I get cosine squared of theta d theta. This is cosine theta. This is cosine theta. Okay, we have to work, excuse me, we have to be careful here because this could be the negative of cosine of theta, right? If cosine theta is negative. But here we don't have a problem because from 0 to pi over 2, cosine theta is positive. Okay? Now, here we're going to use our cosine squared of theta is 1 plus cosine 2 theta divided by 2. So r squared, 0 to pi over 2, 1 plus cosine 2 theta divided by 2 d theta, r squared times theta over 2. I always put a minus here because I'm going to check it later. Sine 2 theta over 4, 0 pi over 2. And now I'm going to check. So the derivative of sine is cosine, so that means I need to make that a plus. Okay, now let's put in our endpoints. Pi over 4. Now, sine of pi is 0, isn't it? So this is all we have. And look, that's what we wanted. Oops. Okay. Okay, so that's sort of the basic idea of what we're going to do. All right, we'll do some problems next.